Hey everyone, I'm Ankit and welcome to my new channel Planet Dev. I'm super excited to have you here. So, a little about me. I have been building stuff for the web and mobile for over 10 years now, working across different industries. Currently, I'm working with Kotak 811, the digital banking division of Kotak Mahindra Bank. Now, for a while, I have been a huge fan of Golang. Well, why? It's simple, it's fast, the way it handles concurrency. It just feels like a breath of fresh air, didn't? Yes, it does. That's why I thought, why not share some of my runtime knowledge and experience with you all? In today's video, we're going to start with building web APIs using plain Go and its standard net HTTP package. No fancy frameworks, just the plain Go. Later on, we will explore things like gRouter or Gin framework, but for now, let's keep it simple and build something. If you are new to Go or programming in general, don't worry. I'll keep the things casual and easy to follow. Let's learn and grow together on Planet Dev. If you have Go is already installed on your system, then well and good. The version of Go which we are using is 1.23.5. If you don't have installed locally, then you can visit go.dev and follow the instructions to install it on your local system. If you're on like Mac or Linux or Windows, you will be having all the options to download and then you can follow along easily. For any doubts, like if you are not able to follow any syntax or any of the keyword for the Go, you can definitely visit the Golang documentation over here, and otherwise you can also comment below on my video. I'll be happy to help you all. All right, let's start. Let's create a new folder for our project. We will be building a APIs. Uh, it is going to be very simple APIs, but let's call it something we'll be building for the auth service, like for example, sign in and sign up. So, and some of the like things which will be required to serve the authentication or the users like that. We'll create the directory with, okay, now let's create the Go module using the go mode init command. Go mode init, and let's name it as pd auth. Open it into our favorite editor. I'm using Z as an editor. Previously, I was using VS Code. You can also use VS Code or Golang if whatever like you're comfortable with. In Z editor, you don't have to like install anything Go related package. It's already by default inbuilt. It is with the Z framework, so nothing has to be done. Let's create our first file, main.go. You can name this file as it is, whatever you want to, but the main package is really important, and the function which will be executing for the very first time will be the main function. For the first file which we are expecting to run in a Go is the package should be main and the function name should be main. This will be automatically executed. You don't have to specifically call this as a main function and then run it. Go compiler understand this very well and it will run this. For printing a simple words, we'll be using fmt.println, and let's see. Welcome to Planet Dev. Let's to run the Go program. We'll have to run go run and main.go, the file name. Welcome to Planet Dev. Yeah, we are able to run it. To build the project, we simply need to go build and main.go. This binary will be available to you. This is the name of the binary. If you want to rename this binary to something else, you can do that. While building it, also you can do it by giving a parameter as O, which is for the output directory, or the file path. So let's say we will be giving it name as uh, bin slash our name of the service, which is pdau auth, and then the file name which we want to run. So now if you see, our build is being present into the bin directory, and if you want to just run the our binary, we can just simply run using that one. So cool. And if you do not want to specify the name of the file, you can simply run by dot. Also, I'll be mostly using this go run dot while in this video. So this will automatically pick the main.go file. If it is any other file, it won't be picking, but if it is main.go, definitely it will pick the same. All right. So let's clear this and move further on. To start any HTTP service, we have to use net HTTP package of Go, like standard library. If you want to use some other library, you can still use that also, but we are going to use with the standard HTTP package. So to start over here, we just need to do http.listen and serve and provide the address of the port where we want to listen TCP connections. So let's say we will be giving it port 8000, and handler we don't have to provide as of now, but with this command, just this command, our application will be starting to listen on this particular port. And let's say we'll also print a message to our console so that we'll get to know like something has happened, like our service has been started. So fmt.println, listening on port 8000. All right, let's try this out. To run. All right, it has started to listening on this port number 8000. If we go to our browser and go to port 8000, yes, we are able to see the request, but it says 404 page not found. That's because we are not handling that out right now. If your server, so this particular function is returning an error, we have not handled the error. This will return an error only in case if it is not able to start your server. So in case of error, we should be handling this error. Like if for some reason, if it didn't start your port, then it should let us know that you are not able to listen or start your application on this particular port. So in Go, we'll be checking whether the error is nil or not. If it is not nil, that means there is something in the error. That means you are not able to start the service. So in this case, we will be simply our log dot petal and the error message, whatever the message we are getting, we'll be just printing it out over here. So just to demonstrate this, we can do like our service is already running on this particular port. And if we, let's say we try to run the service again, and this will not run because we are already listening on this particular port. So this should throw an error and we should be getting that error. So yeah, if we are already listening on this, we are getting an error that listen TCP 8000 bind already in use. So yeah, that we have handled. If we have not handled, then it won't state this particular error to us. It will simply exit, but without any error. All right. So now to handle particular requests, we need to provide the handler. Like if I'm visiting // page, what my server will respond. If I'm visiting a API endpoint, for example, slash auth slash sign up, or whatever the path you will be building, it should how your service will be handling that particular request. So for that, we need to build our handler functions over here. So to create a handler function, we have to create using the net HTTP package, which is http.new server mux. And mux is basically, we call it mux as a because it's a multiplexer of your request. And if you pass this particular mux over here, that means like we will be like further on writing the paths to handle it. But this is the way to provide this handler to your HTTP listener. And when we have passed it as a nil, That time it was using the default multiplexer which the standard library has already created for us. So either you can like create your own, or the one which is already provided by the Go library, you can reuse that also. We are creating our own because we have to define our paths and we have to apply some of our logics also. So that's why like a better control on for us, we can create our own. The default one is http dot default server mux. So this is equivalent to like whether you just use it like mux as a this one and you are providing it, so it's the same thing. And then you can also create your paths over here also, mux.handler function, and provide the path. And then uh, the function you are passing over here, it's a response writer and the request. All right, over here you can write the response, like whatever you want to write to the page or this response, you can just write it over here. So first we'll tell what is like status coach which we are sending, which is let's say 200, or instead of writing 200 we should be writing with a uh, from the HTTP package as a status. Okay, much better readability. And if you go over there, it is again say number 200, and then we can write with the w dot write. It takes slice of bytes which we can give as a string. We'll give a input as a string and it will convert those into the bytes and will be written to the this writer. So let's write welcome to planet F. And now if we're running the service again and visit the page, we should be getting the response as welcome to planet Dev. Super. But this will be handling all of our requests like this way. Like if we go to any page, then this will serve the same response because we are not handling other paths and we are also not handling the not found path also. And this we are handling in our default server mux. So first we'll be changing that to our new server mux which we have defined. Let's try to create one more handler function. There is another pattern which we can use over here, like we can create it using the handle as well. Over here again the path, let's try to give it as a status endpoint which will tell us whether our service is being up or running or not. And over here, so this function is, we cannot like pass any regular function like this one over here because this function requires like it should satisfy a interface which says like if you go to the handle function and it is expecting a handler, what it should satisfy, it should have a method as a server HTTP. So for that shortcut for that, which is http dot handler func. And if we pass any function to this particular function, it will convert that particular function into a handler function. So over here, if we pass, like create the function as a uh, our response writer and with the request, it will handle that. So now over here, we can also, similar to this, we will be like telling the status of this particular response, which is HTTP, let's say 200 only, which is status okay. And then we can write the state, we can also write using the fmt dot f printf, which takes the writer and uh, takes the string, and it can also like you can also format a string also, and then it will write to the writer, to your HTTP response writer basically. So over here we'll pass the writer whatever we are receiving over here, passing the simply, and then let's say status okay. And we have anything to pass over here? Not really. So we can simply use fprint. With the fprintf, it will actually allow you to format the string based on the specifier, but that is not required. So we can just simply use this. And by default, like if you won't be specifying this write.header, it will take consider it as a 200 request. So we can also skip this as of now. So let's rerun and try it out. the path, welcome to Plan, and if we have status as a path, it is responding us as okay, cool. Now, like, what's the difference between this one or this one? Of course, like this one, you can create your own handler interface and then pass it over here. That is like another one way. If you have to go into very deep and uh, integrate your own handler function and interface you want to build, then you can build that also. If you want to rely on net HTTP standard function, then you can simply use handle func itself. Now you will say that it is, we have not specified any like what kind of HTTP method we are allowing over here. So by default, it is expecting all the methods. So now if we uh, now let's say if we try to send a request like post request or patch or post put request, then those requests will also be served over here. So let's say if I'm going with the HTTP and I'm putting a method as post, and which will be I'm putting it on HTTP localhost 8000 and the slash. So this is also giving me a welcome to Planet Dev response, which I have worked like which I have integrated with the get method only. Like I was expecting it will be on the get method, but it is handling all the methods. So to handle that thing, the new version of Go starting from Go 1.22, it is allowing us to specify that over here. But before that also you were able to do that, and that was using r dot method. Like you capture the method of your request and then handle it like this way, method equals to this one, and then check if method is equals to http dot method get, and then you will handle all this particular thing. But now it is, we don't have to do all these checks. It will handle via the string pattern match itself. So now it will handle only the get request at the index way. We can do same thing for this also. Let's do it as a post request. All right, let's try this out. Let's rerun our service and do a post request to the index. Method not allowed. Super. And now if we do the same thing using our get request, we should be getting the response. Cool, fair enough. Let's try this out. Same thing for the status also. Like the get the status method, but it is giving us as welcome to Planet Dev. It should not, but it is giving us because it is trying to match the index route, like it is present over here, and that is getting matched over here because the get method is get slash status is not available, and this particular thing is out of scope, but this one is still there in the scope, and it will match any other string also. Like if we go to, let's say instead of status, if we do health also, then also it will give us the response the same back. So to do that, to handle that particular thing, we'll be handling just right after this one. Like if your exit path match is not there, then it should return as a 404 not found kind of error. So let's check the status using the post method. Yeah, it has responded with it. Okay. And if we check in our browser, we should not be getting anything, like of course like the default handler. So to check whether it is to check whether it is our index route or not, for that we have to still do it manually in the standard library. We don't have any other way as of now. So what you can do is r dot on the request object, you will be getting the URL object, and from there you can see the path object. Well, so now we'll be checking whether this particular path is equals to slash or not. If it is equals to slash, then only we'll be serving the request. Otherwise, we will simply return it. And I'll do it in the opposite way, like error check first, and then so over here we'll return the error, which we can return by http dot not found response writer and the request, and simply return from here, and then we will serve the request. So now if we go to any path other than the index path, then it will give us the not found error, the default error message which we have seen in the first place. So let's try that out. Run it. Now let's try our health path. It says 404 page not found. And if we do via post method, then it says, oh, the health we have not defined. It is the status which we have defined. My bad. Status, yes. Okay. And same thing for the index route also. This is not allowed, but if we do get, this will give us the response which we are expecting. So this is like handling get and post methods. Till now, like this is fine. But now let's say when you are handling your request, we have to handle in a better manner, like how much time you are taking to read the request, and the further on connections are coming, how much time we should be waiting, and while you are processing your request, how much in time you should be responding back. So for all those better configurations, we have to define our server with a more valuable configs, and that we can do by defining the HTTP server, which is, let's say we are defining a server, a reference to the http.server interface, and over here we will be defining the things over here. Like the first thing will be the address, this port which we are specifying, and this time we'll be taking this particular value from a variable, and we can take that from the environment variable. To take this value from the environment variable, we simply need to do import the OS package. If we do just enter over here, it will be automatically imported over here. I have not mentioned that before, but we have to we have like included all the other packages from the standard library automatically, and you can write them also. If like your editor is not supporting, you have to add it, but my Z editor is automatically supporting it. So if I just type OS, it shows me that OS package is from the standard library. If I press it enter, it will add the package into our import statements. Now I simply need to do get env and key of the environment variable, which is, let's say, port. So this will give me the response in like string format, and we can simply pass it over here. And then what else do we need to pass? We need to give the read timeout over here, like how much time it should take to read my request. If it goes like, let's say, beyond 10 seconds or beyond 50 seconds or 60 seconds, my server will keep on busy in reading those requests. Ideally, in an ideal scenario, it should not go beyond like 2-3 seconds or max 5 seconds, but we will be keeping it a time of, let's say, 10 seconds for now. That's like ideal kind. So to define the time in Go, we have to specify the number, and what is the unit of this particular number. We have to specify by time.second, milliseconds, or minute, or anything you can define. Similar to read timeout, we will also be defining the write timeout. To write the response back to the user, we can say like our request should get finished in 10 seconds. If it is taking more than 10 seconds, that means we are taking too much of time, and we'll cancel that particular request with a timeout error. You can, in production environments, like you can consider this value like how much your actual service is taking the time, whether you are doing a couple of async operations, or you are doing all things in the synchronous manner, like you have to upload a file, you might take some more time over here. But if it is simply putting into a DB and responding back, it should not take more than like 2-3 seconds in the time. But if you have a heavy processing, then you should be considering that. You can also like give it like 30 as a timeout. Like if you are using API gateway from the AWS, you can specify like 30, because API gateway is also having a timeout of 30 seconds. So we'll be keeping it as a short for now for in our development environment. Similar to that, we'll also have a settings for idle timeout, which is actually when you are serving a one particular request and then you are serving another request on your application. So how much one particular connection, so that means like you have got a one particular request, your TCP port has been open up for that particular request, it is being serving your request and then closes it. But if it closes it, the next time the request is coming, it has to again open it and then close it, the session. But instead of that, if we keep alive our session for some time, so how much time that we need to keep open that particular port, that is the ideal timeout. So this we can keep like 60 seconds or 120 seconds. So if within the 60 seconds, if we get a next request, then it will reuse that particular TCP connection for our that particular next path. So we can keep it 1 minute or 2 minutes, that kind of thing. Let's give it as a 60 seconds as of now. You have to measure and then you can do it. The other things which we have to specify is this handler function. So the way we have specified over here, the same way we have to specify it over here also. So then handler, again this type is http.handler. It should be satisfy this server HTTP function by the handler interface. So here we'll be providing the same as Mux. Now that we have all our custom config, what we can do is simply server dot listen and serve. Rest everything will remain same. Cool. Over here, if what we can do is like if we do not specify the port like by environment variable, there should be some default value. The other thing which I want to do, like what are the value we are getting over here and which we are specifying over here, what we can do is instead of hard coding it, we can just specify the value from the server itself. So let's do print f for formatting our string and then specify the port, which the specifier is %s, and from the server what we can do is the address. So let's try this out. I also want to like specify the default port. Like if I do not get any value from the environment variable, I also want to put a default value. So if port is equals to nil, in case of strings, we have to check with the empty string value only. We cannot check with against nil. Like that's we can check with the against the structs or pointers. We can check. For a number, it will always we should be checking with the default value if nothing is being assigned, which is 0. So over here we can specify the default value as, let's say, 3000. So if I do not specify the port environment now, it will start on the port 3000, and if I specify the value, then it will be using that same value. So let's try that out. So first let's say go.run. It says listening on port 3000 and it says some error like it is not able to start on that, and that is because it has to be this particular thing, like it has to be an address over here, because this is an address port, this is not just a port we have to specify. So what we can do, like whenever we are putting a number over here, we can do fmt.sprintf, and which will be %s and the port, and before that we'll be putting a colon over here. So this will write it as a colon and then 3000 in a string format, and we are using sprintf, that means like it will output over here and assign that particular value to this address, like it returns the value rather than printf, which was writing to the standard output, this particular thing, fprintf, which was writing to the writer, this particular. So over here, this will return the value rather than writing it somewhere else. So now let's try this out. Go.run, and now we are good. Listening on port 3000. So let's try this out. HTTP localhost 3000. And yeah, welcome to Planet Dev. Super. And if we specify the port over here, let's say port equals to 8000, and now running it. Now we are listening on the port 8000. So if we do 3000, we don't have anything over there. But if we do on 8000, we are getting the response. So this is the way of like starting your application. There will be like further on, we'll be adding a couple of things other over here, like graceful shutting down your application. Let's do it a bit later. For now, let's refocus back to our handlers. Now, like you might be seeing, like this is a bit clutter that I'm writing everything on over here itself. Let's split this out first. Let's take this particular function and write it over here. Let's say I'm naming this function as an index handler, and we'll be keeping it over here. And similar to this, I'll be taking this function out and naming it as a status and pass it over here. Now this looks better. Like further on, you can like move these functions into other files and then use those things from here. But for now, this is fine. Next thing which we'll be considering over here is regarding the middlewares. Let's say one of your request, something has happened in your code which was not right, and because of that your server crashes. So let's say something happened over here and your service is getting panicked. That means it is getting crashed. So let's say something went wrong. So now let's say we are starting this service on our HTTP port 8000, and if I'll hit the HTTP API, now our server crashed. Now if we go to status, I'm getting as a 404 page. One second. All right, it is handling right now, but it is this particular go routine which we have like started go 35. It was exited, like it's in a exit state, like it's not able to run or take on the further request. But Go is having like multi uh, Go routines are being running for each of the requests, so that's why like it is able to handle it. But in case like we want to recover from this particular error, we will have to like handle that particular thing, which Go is also giving a specific thing. So now if you see, if I hit it again, which will be in the different Go routine, which is 4, which was running over here. Now it is in different one. So that particular Go routine, we have to recover those things. So to handle that, let's build a middleware. So how do you build a middleware? So let's try that out. In Golang, so as we have this handler functions, it is in very similar way. There is no difference at all. So let's try a recover middleware, and then we also try a logging middleware. All right. So function recover middleware. It takes a parameter, a handler function. Let's take we'll call it as a next, because middleware will be from one middleware it goes to the next one and then goes to the next one, so it takes like what it has to go afterwards. And what it will return is also a handler function, so it will take a handler. It will also return a http.handler interface. It will return a http handler function. Again, like we have seen this previously also, like to make any function compatible with the handler function, compatible with the handler interface, we can use http.handler func. And now we can define our request response writer and the request object function. So whenever this function will be called, we'll be expecting this function to be called. And over here, the first thing, or the thing which I have to do is call the next dot server http and pass the response writer and the request object what we have received from the middleware function. Now what will happen is when we will be passing this particular function to our handler, and this particular thing, like whatever we are getting over here, this will be a handler interface. So this should be having a server http method, and this method we are calling. So that means we do something over here, we can do something over here, we can, after that we'll running the next thing which we have to run, and then we can also run anything which we want to do post this particular execution has been completed. So to try this out, let's say we'll be printing fmt dot println, let's say recover middleware, and over here we'll be writing as middleware ends recover middleware ends. All right, so and now we need to apply this middleware to all of our handles. So to do that, before this we have to pass our middleware. So to do that, what we can do is uh, we have to call the middleware function, what it takes, like what next it has to go. So which is again our handler mux, and what it returns is also a handler. What we can call is uh, handler, we can call it the main handler, and then we pass it over here. So now our middleware is applied, then we are passing our routes, and then so the first this will call the recover middleware, and then the routes, like it will handle it. Let's try this out first, and then we will actually handle the recovery middleware. Run the server using go run. Now we'll call our status API. I'm sorry, this is running on 3000 port now. It says returns as okay, like our service is running fine. And it says recover middleware, the first print log which we have done. And then it says recover middleware ends. And before that, it has went inside the our index handler, and then it prints. So to verify that, you can always like print inside this handler also. And the name which I have given is again a typo. I can rename it to index handler, and let's print something over here. Let's fmt dot print ln request accepted at status handler. All right, and similar thing will be doing at the index handler as well. All right, So now try it out. Okay, I'll also want to like print a next line after this one because it is merging and it is not looking good. So to do that, we'll simply add a slash n for the next line. So now if we're running, listening on this particular port, send a request again to the status. So now we will see recover middleware first statement, then we have accepted at the status handler, and then the middleware ends. Similarly, if you see uh, on the index route, even though it will panic, it will still run the middleware, but it won't run the what comes after the middleware. The request has the middleware starts, the middleware has accepted at the index handler, and then it goes away. All right, so now we have to handle this recovery. To do that, we have to do something over here. So to do that, in Go, there is a special keyword which is a defer. What it does is whenever something happens wrong inside our function, and at the time of exiting from the function, this defer function, like whatever we run after this, will be executed. And over here, we'll be defining a anonymous function. Like we don't have to give any name to that, and then we will call it immediately. If anything happens wrong, I mean, like this won't be called immediately, but this will be called whenever function is getting exited. That means we'll be we are not calling it straight away. This will be called, then this particular thing will be called, and in between something happens wrong. That means this function execution has been completed, and this is exiting from this particular function also. At that point of time, this defer function will be called at the time of exiting any manner, like whether it's panic or anything. So this will always be called. So we'll be handling our recovery of this point of time. Go is like providing us a method to recover from a panic. So if your panic happens, that means your service is getting crashed. And to recover from the crash, we are having a inbuilt recover method. And it will give a, if it fails to recover, then it will give us an error. And this is special syntax in Go. Like we can assign this particular value, like whatever, if error comes to this particular variable, and then using the semicolon and then error not equals to, we can check whether this particular variable is nil or not. So that means it's a shortcut kind of thing. You're assigning a value to this particular function. In the same statement, we are using another expression as error not equals to nil. That means if recover happens and there is no error, then you have to print out that something has went wrong. So over here, when we have tried this particular thing, we have not got anything, like the server crashed and the response was like abruptly sent. Not this case, but the other case which we have done previously. So over here, we can handle that error now gracefully. What we can do is, first thing what we can do is we can definitely log our service that something has happened, which is like, let's say, recovered from the panic and the error which we have received during the panic. We can also log that. So to do that, you can specify the specifier, which can be s also, because error will be printing into the error dot error method inside this. And then we have to throw an error in your format, like whatever the API formats you are using from your service, you can use the same way, or we can simply return an error in a standard default way of a standard library. So over here, we just need to specify the writer, response writer, and the error message, which we want to tell to the customer or the API user. Let's say we'll call it as internal server error. And the status code which we have to send will be like, let's say 500. Then you will be using http dot status internal server error. So now in this case, we'll be getting a better response to the our API consumer. So let's try to run this. Now our service is running on port 3000. Now it says internal server error with a proper HTTP status error as 500. And previously it just hung up. And we can also have some logs. So like it says recovered from panic, and what was the error message like we have got. At the runtime, we wouldn't know like if something has gone wrong, then we'll be printing that error message also. So this error message which we have given for now. All right. So this was like our first middleware. So similar to this, we can also build a another middleware for a thing that will be building a logger middleware. So what it will does is like any request which is coming to us, our application, it will log its input and what it is sending back. So this is pretty important for our tracing and finding bugs on the production, that we are receiving the request, what request we have got. So we can also measure our like how much time it took on the server itself. If some of the endpoints are taking more time, then we can analyze like things on that. So to build another middleware, let's start with the creating a function as a middleware. What it takes is a handler, http.handler interface. It will again return as handler, and this will return a http.handler function, and this accepts a request response writer and request in the response. The first thing we need to do is next.serve http. If you're coming from Node.js, specifically in the middlewares, you over there also you have to call in your middleware that next only. You don't have to like specify the method on this, but here you have to specify the which method you're calling from the next. So because it is having a interface of HTTP handler and which has a method on that. So that is the thing. So here we will pass the writer and the request object. So now we are ready with our logger middleware. And now before the request, if we want to print something that we can do, let's say log.print, and over here, let's say we have received the request, and we'll print the method, and after that we'll print its URL. So we have taken like two specifiers format. So from the request object, we will be having its method name and its URL. You can specify the path also, or if you specify just the r.url. And if you want to print its like for example like response or other things, I'll add those methods like a little bit later, but for now this is good enough. Let's restart our service, and if we do visit on this particular path, now we have printed. We have not applied our logger yet. That is another thing. First, we have to apply this middleware to our handler. This is like first middleware which we want to apply, and after that we want to like apply the logger middleware and then the handlers. So there is a chaining we will have to do, and which can be done. So how does it look like? We have the mux defined like routers over here. We are defining logger middleware and passing this one. So, and then we are having recover middleware, and inside that middleware, we are passing logger middle, whatever like we have written. So this will be executed first, then it will call the next function. It will go to this particular logger middleware, and then the next will be called, and then this will go to the this our router handlers. So this is kind of like you have to apply multiple middlewares, then you will be having to apply it all inside the chain. So now if we'll see like how it is handling our request now, the first one, which is giving us a panic, we have to remove that, but yeah. So now it says this, like the timestamp which we have got from the log, that's a default log package. We'll be later on building a better logger with the structured outputs that we'll be building, but right now let's use the default one itself. It is printing the method and the URL which we are getting. We are hitting on the slash route, that's why. If we do on the status page, uh, for the post method, of course, we are getting the right response. And over here we have first recover middleware, then post method and the path, what we have done on the status handler, and this ends. So now if we can do one more like good thing over here. Let's measure the time it takes to handle that particular request. So that we can do by, let's count our start, which is time dot now, and then once our request has been finished, we just need to print that out. So to do that, let's copy this, and over here we will be putting a duration, and that could be time dot since the time which we have created over here. So it will calculate the time since the start of this particular request. We have not specified the specifier, format specifier, string specifier. Yeah. So now it should print the initial at the time of request is being raised to this particular function, and when it is sending the response back to the client, so how much time it took, it will print that also. Let's rerun and hit the request again. So this took like 183.292 microseconds. All right, before moving to anything uh, further, let's clean this up a little bit so that like we won't be building everything in our one single file. So what we will do, let's remove this panic first. We should not panic this way, and put these functions into its own files and the server also into own files. We will create a folder structure. So let's create a couple of folders which will be required. The required is the internal. This internal function, the folder, that means we will be writing all the internal parts of our application. That means our business logic will come inside this particular folder. And if any reusable thing is being done, is we are creating, or any external package if we are integrating, or any other things like for example Docker or any scripts if we are writing, then we will be having anything uh, outside this particular folder. This will be completely having related to only to our this particular application. There will be creating the one more directory as package, and we will be also creating a starting point of our application. Like this won't be a part of our internal. This is only the about the API, but how you are going to start, like you can have one application, you can have another application. For example, you are processing your queues, like workers or some other background process you want to do, that you can also do. Or if you are having another application for your UI or for the front end, you can also create inside this directory itself, and you can serve them from here itself. So command cmd is a short. We'll be writing all of our entry points of our all the application which are present in this particular directory. And inside the internals, we will be having a couple of other directories we'll be building shortly. Inside CMD, let's create another folder as API, and inside that we'll be moving our main file. Okay, and that is because like we are building an APIs for this particular service, so we'll be starting from there. If you are having another, like for example, a UI, then you will create another UI as a folder as starting point for that. Now inside the internals, we'll be like gradually increasing more folders, you can say over here, and then as per the requirement, we'll be adding those later on. But for now, we'll be creating only for the server and let's say for the middlewares. So let's create folder here for server package, and then we will also be creating for middleware. And then further on, we can have our other folder structures. If you want, like, based on the type of your files. For example, you are creating models, handlers, or repositories, you can have that kind of structure. I personally like to follow a domain-driven kind of pattern. I like to create a particular domain, for example, authentication, and all the authentication related files will be in that particular directory. So let's create one more Z domain over here. So inside the server, let's create a file as server.go. Package would be server. Now we just need to move from here to there. So what are the things are being required to start the server will be moving over there. And what is that? This particular thing, server, definitely we'll have to move the starting point, all of this. Yeah, for that, like we have to create a new function as a new app. You can name it anything you like to have it and paste it over here. So what it requires is handler, code configuration. Have to move this particular logic also over here. Now we need to do for the handler. So for that, we will be creating a separate file as a, maybe call it handlers or routes. Let's call it as routes, a very generic to all the languages. We'll give it as a same package as a server. Within the same package, we can directly use the functions. We don't have to import and then use it. So if I'll create a function as a setup routes over here, then I can just simply use this particular function as a setup routes. And what it requires to return is http.handler, because that's what like handler is or is complaining about, that should be, it is missing a return of handler. This satisfy. So now we'll be moving our setup routes code to the routes file, which is this one. And then return in the end. Return works. Now it is complaining about this middlewares and also the handler functions. So middlewares, we can move it over here. Let's move it to individual files. We'll create two separate files for recover.go and another file for http.logger.go. And package is middleware. Let's move our functions from here to middleware files. logo, cut, and paste. Similar to logger as well. Sorry, I mean recover middleware. Cut from here and put it over here. Packages middleware function recover middleware. Now we should be able to import this. For that, you need to get the middleware package from our directory, not from anywhere else. So pd auth middlewares and then the function name. So now it says like it doesn't, our like autocomplete is also not doing it, and that is because we have not exported the like this is a different like separate package from the package which we are using, which is server. Now we are importing another package within the server package, so that's why like we have to export our functions from there. And to do that in Go, it's very simple, and sometimes like it's confusing for the other programmers which who are coming from other languages. We have to export this function to other packages. We just need to capitalize this first letter. So if it is capital letter, that means it is exported and it is available to other packages as a public method. And if it is a smaller, that means it is private to this particular package only. So if we do capital L with the logger middleware, then it will be available in the routes server package as well. Similar to this, we will have to do for recover middleware as well. So now if we do middlewares dot recover middleware, and similarly middlewares dot, okay, I think this is not taking just because of this. Middlewares dot recover middleware. I'm sorry, like it is happening a lot. I'll just clean this middlewares dot recover middleware, and we just need to pass marks. Simple enough. Yeah. And this handler will be returning. Cool. And now we need to get these handlers so that we can get it from different file. So these are like root kind of like handlers which will be directly on my slash like index path, and we'll be like dividing our further APIs to our some other paths, like for example slash auth or slash customer or users kind of like paths will be having a different endpoints. So for that I'll be creating, and these are like my generic paths not related to my business logics. Like I won't be serving any traffic as of now, but if you have any business log, definitely then you can define into a domain. But for now I'll be creating these as a, you can say either I can create it inside the server itself or a separate folder over here for the root handlers. But now I'll create it here itself, like index handler.go. Package should be same server, and I'll just copy it from here. And similar to this, I'll be creating one more file for status handler.go, and which would be server. I'll put the function status handler, and I'll capitalize the name of the function. Or we don't need to actually, because it's in the same package, we can simply use it over here. So on the routes, it will be, yeah, directly accessible, and similarly this is also accessible. So now over here, do we have anything? So now we need to import the server package from our pd auth internal server and then the new app. So what I will do is app is equals to, it's not returning anything right now. Yeah, it does. It is not returning. So instead of like starting this particular method over here, hmm, what we can do is we can start it at, like, we can start it over here also. Instead of like starting it over here, from here we will be just returning it as a function. So return, or better, let's do one thing. Let's create an interface for this server application, and then uh, return that particular interface as a response to this particular from this function, and then start it from the main file. So that, like, you, if you have to start application any number of time or wherever like you want to start, you can have a single particular function, and then you can just start it. Like, we are controlling like how you want to start the application rather than we defining our, I mean, like, we have to define this server.listen either here itself or in main.go. So instead of that, we'll be giving a clear function to start this. So for that, let's create a struct, which, let's say, we are calling it as app struct, and what it should contain is a HTTP server, which is, let's say, name it as server, and it should be a type of HTTP server. All right, this particular thing, this particular server, we are creating a type struct. Now we need to return the same thing. So we need to return the app. So here, once you have created your server, like configured your server, then you can simply return app. Like, we'll be creating a struct of, I'm sorry, we'll be creating a object, you can say, of this particular struct. And over here we'll be assigning the server, which we have defined, and which is server. Now, when we will be getting this particular object, we will be able to run using listen and serve method over here itself. This also doesn't look good to me. So instead of that, we should be having a method to, like, just simply, you are getting the application and then simply start. So this will be easier for later on purposes. Like, if you have multiple kind of like applications you want to start, let's say you are running two services, or you are having a background service, or you also want to serve a public files or UI. So you can like serve all those your applications from a very simple, easy to use APIs. So let's try to do something like this. So for that, we have to create methods on our struct. So this, you can think, is as a, in a classical object-oriented programming, as a class, and the class has some members, and then it will have its methods also. So these are the like member, like I say, server is a type which we have defined now, and we are able to create a struct, the object based on that, like created over here, and assign the values. Now we also want to assign some function, so that like we can do app dot, like this is an instance of this particular struct, and then we will want to like call the functions on that particular struct. So to do that, Go has a function of receiver functions. So to attach that, or to attach any unknowingly to this particular struct, any method, we just need to, the function should have a receiver. That means we are, this particular function is receiving methods on this struct. So that means it is assigning a value simply. So let's say we are calling it as app, the type of the struct. So this can be either the without the pointer or with the pointer also. With the pointer, that means like we are referring directly to this particular struct which we have got. So that's why we need to use this one. The name of the function, let's say start, and that's it. So what it will do is, like, it will get the instance, like which this particular thing which we have created, it will be this particular instance will be available. So think of this as a if you are talking other programming language as this in your JavaScript, or we used to like refer as a self. So now I'll be having all the methods available which are like part of this particular strut. So now I'll have this particular server is already available to me, and now I'll be accessing this particular member, like the member of my strut, you can say. And then I can simply call listen and serve. That means I am starting the application from here whenever I call a start. So my this particular thing, like from where my program is being starting, doesn't know like how this particular application is getting started. So for this, it's just a simple start function, and this function internally does whatever like the methods it has to call. It could be listen and serve on a HTTP request. It could be listening and on serving from the UDP port, or any other port if you want to serve, or just a simple static file servers also. Now let's add back our logs. Will be, yeah, here we have. So these things will be handling it over here. So now this will change to app.server.address. Now our port will be like starting on this particular thing. And then that we have already started, we'll just capture the error in case something went wrong. Then we will be good to go. Super. All right, so we have our starting point of the application very neatly, separately we have done. The route setup is all separate over here. Index handler, the status handler is all managed in a separate file. If you want to like further distribute the like what a status is being doing, you can create another file or folder and then handle it over here. Now you got the idea of like how the packages, like same packages within the same package it works. You can also create this status handler itself into a separate, like inside the domain you can create a folder as a status or health, and then add all the functionalities. You can provide the CPUs details, memory details, and other details into those status handler, and then you can serve it as it is. So another next thing which we have to do over here, till now we were just serving the text plain text as a response. But now we are building REST APIs. Basically, we have to send the response in our JSON format. I'll create a mux.render function, and the path will be, let's say, post method of, let's say, auth slash sign up. Now I have to create its handler. For this, I'll be creating into a separate file folder. Say, let's say inside the auth package, and inside the auth package I'll say sign up dot go. All right, so over here I'll package is auth, and function is, let's say, sign up. And I mean, like what it will take is a writer, which is http dot response writer, and a request reference to the request object. So http dot request, and then we'll be sending back the response. This sign up handler will be attaching it over here. So now we'll use the auth package, pd auth slash internal domain auth, and then the sign up handler. These routes we might be moving it to a like segregate, like because if you have 10s or 20s or 50s kind of like paths, it's like difficult to, or not easy to like see all this long list of API paths. So we'll be segregating that also, but for now this is good enough. So inside this we need to handle a couple of things. We need to read the a request body. We need to validate the request body. We need to do some other validations for sign up, and then we have to, let's say, create the user, and then we have to response handles errors also, but we need to send the response that the user has been created. So till now we were not sending the response in our JSON format, so let's start with that first. To send the response into JSON, we need to do is we need to write the header first by specifying the method of the header as content type application slash JSON. This will set the content type as a JSON. Dot write header first. Yeah, of course, like http dot status okay, and then we need to write into the JSON. To write into JSON, we have to encode our data. So the data, let's say we are creating, you have a user, and then you are assigning the response back. Result, and which is of type, let's say map of string, and then again string. Okay, so now here we are creating that status, let's say okay, and the data which is we want to send for the as a like user object. So now let's keep it as a nil for now, and we cannot like set as nil because that's a string type. So let's do it as any, like you may see Go as a interface of type anything, like it can have anything. So now in the later versions, like versions of Go, this represents as any itself, so nothing to worry about that. Now this result object we need to write back to the our response writer, and then we can also say message created. Okay, or the user created. So now we need to set this particular response back to this response. What we need can do is you can simply write using the bytes also, but this will not work because this is a map, and the bytes it will accept, like string can be converted to bytes but not directly. So to do that, we need to encode our data and then send it back. To write this particular result, we have to encode our data. Let's do that, like we have a JSON encoder. So we share that new encoder, and it takes our writer because it has to write it to somewhere. So let's name it as encoder, and from the encoder you will be able to, sorry, I have imported from a wrong package actually. So this should be JSON from the encoding.json, and the new encoder which takes the writer as a response writer as a input. So now we can do encoder.encode and the value which we want to specify, which is this particular parameter. Yeah, now so as we have specified this writer to this our encoder, that means like it will write this particular data to this response writer. That's it. This is all we need to do for sending the JSON response. Of course, like we should be handling the errors, like it must be returning an error which is there. So if there is an error, we have to handle that case always. So if error is not equals to nil, that means if it is not an empty, we have to handle that case. So in that case, we'll be simply returning in http.error, and that was not able to write into the JSON. We will be sending a plain text kind of like error. Let's say internal server error, and the code would be 500 something. Internal server error. Try this out first, that we are able to send the response in the correct format. we can remove this. Like this is not needed. This was imported mistakenly. So now let's start our application. Oh, by the way, we have not verified our initial changes that like we have when we have split it into multiple folders and structures. So let's do that first. Okay, remove our binaries which was there and from the bin directory also. Whatever we have because those were like older builds. Clean that up. Now we need to run using go run and from the cmd package we have to run this particular file. We are able to run this on port 3000. And let's try call our status endpoint. That is all working. Now let's call our endpoint as auth slash sign up. Oh, we are getting a response back in the JSON format, nicely formatted as well. And it says the content type as application JSON. And I just realized that this video is taking quite a longer now. Let's try to split this into multiple parts. I'll see you guys in the next video.